Okay, let's look at question 2 in our review. Okay, we're doing some limits. Okay, so in part A we have a rational function, and we're taking the limit as x goes to 2 of x squared plus 5 over x minus 3. So if we have a rational function that is a fraction, an algebraic fraction, and if the denominator is not equal to 0 when we substitute in the value that we're approaching. In other words, we substitute in 2 into the denominator, 2 minus 3 is not equal to 0, then we can take the limit by just substituting in to the rational function. Alright, so in other words, in this case, since the denominator is not 0 as we approach 2, we can just substitute in. This is similar to taking the limit as x approaches a value of a polynomial. Then we can always substitute in. There's no denominator in a polynomial, and we can always just substitute in our value. Alright, that was our first limit rule, and this one's our second. So here we can just substitute in, so we end up with 2 squared plus 5 in the numerator, and 2 minus 3 in the denominator. So here we have 9 over minus 1, which is minus 9. Minus 9, so that's the limit. Okay. We have a different situation in part B, because in part B the denominator is equal to 0 at the value we're approaching. We're approaching, x is approaching 3. The denominator is x minus 3, so we have 3 minus 3 when we substitute in 3, so we can't just substitute in. But we have another limit rule that says that after we reduce, if the denominator is no longer 0, if we can reduce, then we can substitute in. So let's do that. Let's see if we can reduce. Let's see if the numerator factors. And hopefully we're hoping for a factor of x minus 3 in the numerator. So let's see, here we have x, and this factors as x minus 3x plus 5. Alright, just check that, make sure that's correct. Minus 3 times 5 is minus 15. Now for the middle term of 2x, we check minus 3x plus 5x is equal to 2x. So this is the right factorization, and we do have a factor of x minus 3 in the numerator and denominator, so we can cross these off. We can reduce, and after we reduce, the denominator is 1, so it's no longer 0 when we substitute in x equals 3. The denominator is 1. So go ahead and substitute in x equals 3, and we have 3 plus 5, which is 8. Alright, so that's our limit. Okay, let's look at C. Okay, so C, we actually have what's called a one-sided limit. We're approaching 5 from values greater than 5. So that's what that little plus means up there from the right. Now notice that the denominator is 0 at x equals 5. The numerator is not 0 at x equals 5, so there's no chance of crossing something, of reducing this and getting rid of the x minus 5. This is not a 0 over 0 limit. Alright, so this limit is going to be either infinity or minus infinity because of this 0 in the denominator. So basically that's all we have to determine. Is this infinity or minus infinity? The denominator is approaching 0, and the numerator is approaching 3 times 5 is 15 minus 2 is 13. The numerator is approaching 13. So 13 on top, 0 on bottom, that means this limit is going to approach either positive infinity or negative infinity. So that's all we have to see, and it's pretty easy to determine which it is, because if we just put the zeros of the numerator and denominator on the number line, numerator and denominator. We have here is x equal 5, and here we have x equal, setting this equal to 0, and solving for x we get 2/3. So here we have 2/3, and here we have 5. So if we approach from the right, we can choose any value bigger than 5, substitute in, and the numerator will be positive. Let's say we choose 6. 6 times 3 minus 2 is positive. 6 minus 5 is positive. So that means that our expression is positive to the right of 5, and that means that this quotient is approaching plus infinity. Again, we know it's approaching infinity because this is of the form what I call 1 over 0. In other words, the top is not approaching 0 and the bottom is. And this limit is approaching positive infinity. Okay, the next expression is the square root of x squared minus 5 over 2x minus 7, and we're taking the limit as x goes to infinity. Now, this is what we learned this type of limit when we graphed functions, and we called this type of thing the end behavior. Okay, so we said that this limit is equal to the limit as x goes to infinity of the leading term on top divided by the leading term on the bottom, that is the term with the highest power. Okay, so in this case we have to include the square root. We have square root of x squared divided by 2x. Alright, so what's that equal to? Well, this is the square root of x squared is x. Well, let me write here limit x goes to infinity. So we have square root of x squared, that's just x, over 2x. Those x's cancel and we get 1 over 2. So this is a finite limit. Finite limit of 1/2. And finally, let's look at, not finally, let's look at E. Okay, so we have the limit as x goes to 2. And we have square root of x plus 1 minus square root 3 over x minus 2. When we substitute 2 in the denominator, we get 0, 2 minus 2. In the numerator, we get 2 plus 1, which is the square root of 3, minus the square root of 3. So we get root 3 minus root 3, which is also 0. So this is what I call a 0 over 0 limit. So we can't substitute in 2 to take the limit in this situation because of that 0 in the denominator. But when we have a 0 over 0 limit, if we are able to do some canceling, then we're hoping, in this case, we're going to try to do some canceling from top and bottom, and then maybe we'll get rid of the 0 over 0 situation and be able to substitute in x equal 2 in the reduced quotient. Okay, so it's not obvious how to find a factor of x minus 2 in the numerator, but what we generally do in cases like this where we have square roots, a difference involving square roots in the numerator or denominator, is we multiply top and bottom by the conjugate. That's a standard trick. The conjugate would be these two terms with the opposite sign in between. So in this case we'll have these two terms with a plus in between. That would be the conjugate of this numerator. So that would be x plus 1 plus the square root of 3. And just multiply numerator and denominator by the same quantity. Okay, because we have to, in order to get an equivalent fraction, we must multiply numerator and denominator by the same quantity. Okay, so if we do that, let's do that. We're hoping to get a factor of x minus 2 coming out of the numerator. Now, when we want it to cross out with this x minus 2, so don't multiply this through in the denominator, just put x minus 2 times this expression, root x plus 1 plus root 3. Just do that. And in the numerator, now let's multiply this out. Now these are conjugates, so the middle term is going to be 0 when we do the FOIL, F-O-I-L, multiplication. Okay, so first times first, root x plus 1 times x plus 1 is x plus 1. Now the outer and the inner cancel, so let's go straight to the last. That is root 3 minus root 3 times root 3, which is minus 3. So notice we do get x plus 1 minus 3 is x minus 2. So we do have an x minus 2 popping out of here. Let me just squeeze in limit x goes to 2 in front. We did, okay. So this is actually an x minus 2. That's okay, so this is x minus 2, which reduces with this x minus 2. We can cancel those. Alright, and so now we have the limit as x goes to 2 of the reduced expression 1 over square root x plus 1 plus root 3. And now when we substitute in x equal 2, we no longer have 0 in the numerator and denominator. So now we can go ahead and substitute in x equal 2, and we get 1 over square root 3, 2 plus 1, square root 3 plus square root 3. So that's 1 over 2 square root 3. Once we take the limit, we remove this in front, this symbol limit as x goes to 2, and that's it. That's our limit. Okay, so let's try to finish this. Part G, I think A, B, C, D, E. We skipped F, but okay, here we have part G. We're taking the limit as x goes to 0 of sine 5x over sine 3x. Now we're going to use this limit that we showed in class, sine x over x. Limit as x goes to 0 is equal to 1. And if we flip that around, we get 1 again, all right, because 1 over 1 is equal to 1. Okay, and now it's important to realize as well that the limit as x goes to 0 of something like sine 5x over 5x is also 1 as long as we have the same number here and here, 5 here, or any positive number we would have, with any positive number here and here, we'd have the same limit, all right, because 5x and 5x are both going to 0 at the same rate. Okay, so this limit is also 1, so we're going to use these to show, these three limits to show that this limit is equal to, well, we're going to try to work in these limits by splitting this up. Let's put sine 5x over here and this sine 3x in the denominator. And if we had a 3x on top, then this piece would go to 1, and if we had a 5x down here, this piece would go to 1, but we can't just throw in a 3x and a 5x. Well, we could put in x over x, because x over x is equal to 1. We can multiply top and bottom by the same thing. That's okay. But here we have a 3, and here we have a 5, so to make up for that, we have to multiply by 5 over 3. The 5 cancels with this 5, and the 3 with this 5. So once we rearrange this quotient, we have this quotient goes to 1, and we have this quotient going to 1, and then we have 5/3 in front, so this entire expression goes to 5/3.